Hey guys, welcome back. Today we're going to talk about solving linear systems by elimination. So in this unit we started off by solving linear systems by graphing, and then we solved them by using the method called substitution. So today is a new method that we're going to be using. Okay, so we need to recall that a solution of a system of linear equations is an ordered pair. Okay, so if you remember when we were doing it by graphing, it was the point that the two lines intersected. Okay, so we're looking for the ordered pair that's a solution to both equations. Okay, so we're going to learn how to add or subtract the equations to obtain a new equation with one variable. Here are the steps. I'm just going to talk you through them, but it's going to make more sense when we do some examples. So the first thing we're going to do is add the equations to eliminate one variable. The second thing we're going to do is we're going to solve the resulting equation for the remaining variable. And then 3, we're going to substitute in either original equation to find the value of the other equation, or the other variable rather. Okay, so let's look at some examples. All right, so we show you the steps on the left, but I'm just going to write it down and walk you through it. So here we have two equations, all right, and we start out pretty easy. Okay, I'm going to line these both up because this is going to become important later. Notice that our x terms are lined up, our y terms are lined up, and our equal signs are lined up, and then we have our constant. Okay, this is actually a pretty good form to get into. You don't have to get into this form. However, whatever form you use, both equations need to be lined up in that form. Okay, now in this very first example, it really starts out kind of easy, because looking at your x terms, you have 2x and then you have a negative 2x. Well, if you add those two together, you're going to cancel out and get 0 or eliminate. So we're thinking of taking this first equation and we're adding it to the second equation. That's why I line them up. So 2x plus a negative 2x is 0. 3y plus 5y is 8y. And 11 plus 13 is 24. Okay, so we're just taking the two equations and adding them together. Then we can easily solve for y by dividing by 8. Okay, so here that's with number step 2. We get our y is equal to 3. Okay, we then can take that y and we can go back to either of the original equations, okay, the first or the second, it doesn't matter. Okay, I'm going to pick the first, and the first one is 2x plus 3y is equal to 11. So if I plug in the y, I get 2x plus 3 times 3 is equal to 11. 2x plus 9 is equal to 11. All right, I subtract 9 from both sides. 2x is equal to 2. Divide by 2, my x is going to be equal to 1. Okay, so now I have an x, I have a y, my solution is 1, 3. Okay, we can check it by substituting in 1 for x and 3 for y in each of the original equations. So if I did that, again, it would be 2 times 1 plus 3 times 3. Does that equal 11? Yes, 2 plus 9 does equal 11. I know that one works. All right, the second one, if I take negative 2 times 1 plus 5 times 3, does that equal 13? Negative 2 plus 15, does that equal 13? Yes, it does. Okay. All right, so you can also put both equations in Desmos and verify the intersecting point with graphing if you'd like, okay? But you will have to know the difference between solving by graphing, substitution, and elimination, okay? Let's look at another example. Okay, so going forward with this next example, we look at the two equations, and they're already lined up in that our x terms and our y terms and our constants are all lined up. Okay, this first example here is also pretty easy. When we add the equations to eliminate the variable, your x terms will actually eliminate because you have a negative 5x and a positive 5x. When you take your y terms, you have a negative 6 plus 2 is negative 4y, and 8 plus 4 is equal to 12. Okay, so we then take that resulting, okay, we solve for our y, and we do that by dividing it by 4, a negative 4, and we get our y is equal to negative 3. Okay, from here we then take the negative 3 and we plug it into either one of the equations. All right, I'll pick the first one. So negative 5x minus 6 times negative 3 is equal to 8. All right, when I multiply, I get plus 18 is equal to 8. Then when I subtract my 18 from both sides, negative 5x is equal to negative 10. So when I divide by my negative 5, my x is going to be equal to 2. So my ordered pair would be 2, -3. That would be the solution. Okay, let me just make this a little bit bigger. So the solution is 2, we'll put it down here, 2, -3. Okay, all right, let's look here at the next example. All right, all right, so now when I look at it, I've got 4x minus 3y equals 5, and -2x plus 3y equals -7. Now my two equations are lined up, so that's good. And again, it's pretty easy because in this case, my y terms can easily eliminate. All right, whoops. All right, my y terms can easily eliminate. There it goes. All right, leaving my x's. So 4x plus a -2x is 2x, and 5 plus a -7 equals -2. All right, when I divide by 2, whoops, I want to do that down here. 2x is equal to -2. We divide by 2 because we're solving the resulting equation for the remainder, the variable. We get x is equal to -1. Okay, now we're going to take that -1 and we're going to plug it back into the first equation or the second, it doesn't matter. So we've got 4 times -1 minus 3y equals 5. So we've got -4 minus 3y is equal to 5. All right, we're going to add 4 to both sides. And when we do that, we got -3y is equal to 9. Divide by -3, and our y is going to be equal to -3. So here's our solution. I'm running out of space in this screen, but it's going to be our x is -1 and our y is -3. There's our solution. Okay, again, you can check it by plugging that ordered pair into both equations, or you can check it on Desmos. Okay, so what's going to happen here, sometimes our equations are not lined up. Okay, so you always want to line up, okay, the equations. All right, I prefer to get them in the form of ax plus by is equal to c. All right, so I basically put my x terms plus my y terms equal c. Okay, so to do that for the very first equation, it's already done for us. So 8x minus 4y is equal to -4. But for the second equation, I'm going to have to subtract 3x from both sides. So I get a -3x plus 4y is equal to 14. Okay, well, I look at that, and lo and behold, it's easy to eliminate. Okay, so I add the equations to eliminate one of the variables, and then I get 5x is equal to 10. All right, 5x equals 10. I'm going to solve for x by dividing it by 5. I get x is equal to 2. Okay, I'm going to take that 2, I'm going to plug it back into either one of the equations. 8 times 2 minus 4y is equal to -4. 16 minus 4y is equal to -4. I subtract 16 from both sides. -4y is equal to -20. We divide by -4, and our y is equal to 5. Okay, so the ordered pair would be 2, 5. Again, check your steps, all right, with a check step or Desmos. All right, next one. Okay, again, I want to line up my variables. We've got 3x plus 4y is equal to -6. I'm going to bring the 3x to the other side, so -3x plus 2y is equal to 6. Okay, when I do that, my x terms cancel out. I'm left with 6y is equal to 0. Okay, so when I did that, 6y is equal to 0. Our y is going to be equal to 0. Okay, we take the 0, we plug it back into the first equation. We've got 3x plus 4 times 0 equals -6, or 3x equals -6, divide by 3. Our x is equal to -2. So our solution is -2, 0. Okay, at any point I want you to pause this video and try some on your own, okay? All right, let's look at the next one. All right, so now we're going to get a little more complicated. If neither variable can be eliminated by adding or subtracting the equations, you can multiply one or both of the equations by a constant so that adding or subtracting the equations will eliminate the variables. So you might have to change the equation using the golden rule of algebra. Whatever you do to one side of the equation, you do to the other to keep that equation the same. All right, so looking at this, let's line this up a little bit better. Okay. So the first thing we were going to do, we're lined up. We have 6x minus 2y is equal to 1. And then we have a negative 2x plus 3y equals 5. Well, looking at it first glance, there's no way I can eliminate one of the variables. Okay, so I'm going to do some changes so that I can kind of force an elimination. What I'm going to do, I'm looking at my factors. I know that I can get my 2 coefficient to 6 by multiplying the entire equation by 3. All right, so my first equation stays the same, 6x minus 2y equals 1. And my second equation becomes negative 6x plus 9y is equal to negative 15. All right, so we're going to add the equations to eliminate one of the variables. So when we do that, we end up with, okay, so we take 6x minus 2y equals 1 and negative 6x plus 9y equals negative 15. Okay, when we do that, we end up with 7y is equal to 14. All right, 7y is equal to 14, okay? And actually it's 1, sorry, I dropped a negative right there. That's a negative 14, okay? We divide by 7, and our y is going to be equal to 2, or negative 2, okay? We then substitute it back into the original equation. 6x minus 2 times negative 2 equals 1. 6x plus 4 equals 1. So when we subtract 4 from both sides, we get 6x is equal to negative 3. And then when we divide by 6, our x is going to be equal to negative 1/2. So our solution is negative 1/2 and negative 2. Okay. All right, so the next example, we have to do a couple of things. We got to first make sure our equations are lined up. So 4x plus 5y is 35. Now we've got a negative 3x plus 2y is equal to negative 9. Okay, so looking at these, I might decide to multiply the top by 3 to get 12x and the bottom by 4. Okay, that might be the easiest thing, or I could have maybe canceled out my y's by multiplying the top by 2 and getting 10y and the bottom by negative 5 to get negative 10y. It's up to you. Okay, so I'm going to multiply the top by 3 and the bottom by 4. All right, and watch what happens when I do that. When I multiply by 3, I get 12x plus 15y is equal to 105. Okay, and then the bottom, I'm going to get a negative 12x plus 8y is equal to negative 36. All right, I'm going to solve the resulting equation, so I'm going to eliminate. All right, and I'm left with 23y is equal to 69. So when I solve that, 23y equals 69, I divide by 23. All right, my y is going to be equal to 3. I plug that back into the original equation. All right, either one, I'll do the first one again. 4x plus 5 times 3 is equal to 35. 4x plus 15 is equal to 35. 4x is equal to 20. We divide by 4, and x is equal to 5. So the solution is 5, 3. Okay, so now we have a couple of additional examples that show our special cases. All right, if I look at the two equations, they're lined up, but I want to make sure I can eliminate. So maybe I'm going to take the bottom one and multiply it by negative 2. Okay, so when I do that, my top equation, negative 16x plus 2y equals negative 2. My bottom equation becomes positive 16x minus 2y is equal to positive 2. Okay, now when I add the two equations together, the x terms eliminate, the y terms eliminate. When that happens, we're left with 0 on the left. Okay, our constants are also eliminating, so we're left with 0 equals 0. If 0 equals 0, that is true, we know that our solution is going to be infinite solutions. All right, so looking at the next example, okay, I've got negative 18x and 6y and trying to get them to eliminate. Well, I know that 3 is a factor of 18 if I multiply everything by 6. Let's try that. So we end up with negative 18x plus 6y is 24. And on the bottom we have positive 18x minus 6y is equal to negative 12. Okay, to eliminate, our 18x's cancel out, 18x minus 18x, and then we've got 0 on the left. Okay, and then 24 minus 12 is 12, but we know that 0 does not equal 12, so this is an example of no solution. Okay, all right. You might want to pause here and try some of the homework, okay, some of the practice problems, because we are moving on to some word problems. Okay, just like with substitution, we're going to have some word problems. A library is having a book sale to raise money. Hardcover books cost $4 each and paperback books cost $2 each. A person spends $26 for 8 books. How many hardcover books did she purchase? Okay, so remember, like with substitution, our let statement is super important. Okay, so our variables that we have in this case would be hardcover books. So we're going to let X be equal to a hardcover book. And our Y will be equal to paperback books. Okay, our whole goal, we're looking for how many hardcover books. So we're looking for our X, but we're going to need the Y as well. All right, so if we have 2 variables in here, we should have 2 equations. Okay, so that's the hardest part, is trying to find those 2 equations. And it's usually kind of buried in there. So hardcover books cost $4 each and paperback books cost $2 each, and a person spends $26 for 8 books. Well, sometimes there's a really easy equation in there, and it's just one word that actually should make you identify what the equation would be. So if we've got 8 books, it simply means that hardcover books plus paperback books would be equal to 8. So a lot of times we overcomplicate things and we don't notice the easy equation. All right, the second equation is a little bit more. It involves money, but hardcover books are $4 each. So if we take the number of books we have multiplied by 4, and then we take paperback books, which are $2 each, we're going to get $26. Okay, so we have our 2 equations. All right, and now because we're practicing using elimination, even though in this particular example substitution might have been easier just because we have a coefficient of 1, we're still going to demonstrate it. Either way will work. Okay, so I'm going to take the top equation and I'm going to multiply it by -2 because I want my y term to cancel out. So when I do that, I end up with -2x minus 2y is equal to -16. And then the bottom equation stays the same. So when I add the 2 equations together, I'm actually going to eliminate the y term, but I end up with 2x is going to be equal to 10. Okay, we then divide by 2, and our x is equal to 5. All right, so right there we have our answer. Okay, we can get it back in and we can solve for the y, but we're looking for the hardcover books, so our answer is 5 hardcover books. Okay, moving on to number 4. Ethan's football team scored a total of 35 separate times this season with a mix of touchdowns and field goals. Each touchdown is worth 7 points and each field goal is worth 3 points. If the team scored a total of 193 points this season, how many touchdowns and field goals did they score? So we're looking for touchdowns and field goals. All right, so that's our let statement. Let's let X be the touchdowns. And let's let Y be the field goals. Okay, so our easy equation, we're scoring 35 separate times this season. That means our touchdowns and our field goals would be equal to 35. Okay, the second equation, all right, we're looking at the total points, 193. So each touchdown is worth 7 points. So that's 7 times the number of touchdowns plus 3 times the number of field goals is going to be equal to 193. Okay, that's the hard part, is getting the 2 equations. All right, now we want to set it up for elimination. I like to look for my smallest or easiest coefficient would probably be 3. So let's take the top equation and multiply it by a -3 because we're going to want them to eliminate. And when we do that, we have -3x minus 3y is equal to 105. And then, -105, sorry. Okay, and then the second equation we had was 7x plus 3y equals 193. All right, so when we take these two to add them up, add the 2 equations, the y term eliminates. We're left with 4x is equal to Negative 105 and 193 is 88. So when we divide by 4, our x is 22. All right, we need to know both of them. So we've got 22 touchdowns, but we need to figure out how many field goals. So far we have 22 touchdowns. And field goals, we calculate it by going back up here. Original equation, x is 22 plus our y needs to be 35. Okay, when we subtract 22 from both sides, we're going to get y is equal to 13. So we have 13 field goals. All right, there's our answer. All right, one more word problem. Okay. All right. Olivia's family drove to Disneyland for spring break. Her mom and dad shared the driving duties for a total of 14 hours. Her mom drove 65 miles per hour and her dad drove 60 miles per hour. If they drove a total of 895 miles, how many hours did each person drive? Okay, so our let's statement would be x is equal to, let's pick mom's driving hours. Drives in hours, okay? And let's let y be dad. How many hours dad drives in hours? How many hours? Okay. If they drove 195 miles, how many hours did they each drive? So let's look at this. They shared the driving duties for a total of 14 hours. Okay, there's our easy equation. All right, the number of hours mom drove, the number of hours dad drove, is going to be equal to 14. Okay, if mom drove 65 miles an hour, that's 65x, and dad drove 60 miles an hour, I guess mom's a faster driver in this case, that's 60y, and they drove a total of 895 miles. Okay, again, this probably would be an easier example to use with substitution because we have a coefficient of 1, but we're demonstrating using elimination. So I'm going to take the top equation and I'm going to multiply the whole thing by negative 60. Okay, so when I do that, and I'll write it down here, I get negative 60x minus 60y is going to be equal to negative 840. Okay, I take that second equation, 65x plus 60y equals 895, and now I can add them together. When I do that, my y terms eliminate, and I'm left with 5x is going to be equal to 55. I divide by 5. My x is equal to 11. So it looks like mom drove for 11 hours, okay? And since dad drove, we go back to the original equation right here to get our y. 11 plus y is equal to 14. Our y is equal to 3. So it looks like dad only drove 3 hours. So mom drove 11 hours. Dad drove 3 hours. And we circle that. Okay? All right, guys. Now, I know these topics are confusing. It is super important that you do the homework. Okay? I can't stress it enough. If you do a practice problem, we give you the keys. Do a problem, check the answer. Do a problem, check the answer. You're not going to understand or how to do this unless you practice it yourself. You're not going to just observe this and understand it. You need to practice. All right, till next time. Next class is our review, and our test is going to be next Thursday for A days and next Friday for B days. So February 4th and February 5th. So don't forget to practice. Bye.